Okay, perfect. Thank you so much for the introduction. So today I will lift the conversation a little bit up and kind of describe, how we are thinking about AI in the enterprise. We have, Sean kindly said, he doesn't need to introduce IBM. We see a lot of customers in very mission critical environments. And so I want to share a little bit how we are looking at the world and agentic and how it's going to change how enterprises are actually deploying, developing the software, testing it, etc. And then, how IBM fits in that picture and how we are trying to help companies. So if you look at agentic AI, this is really we are kind of in the pre and the post era, I think. So up to 2024, we were kind of in the chatbots. Our main problem was how do we build these and build and run models? How do we do large scale training? How do we do inferencing? Agentic, in that time frame right now is only 1% of the market, but it's expected to grow to about 30% of the AI market. It's going to be an $18.6 billion market in 2027. And so we are effectively going from chatbots to automation, digital worker era. And this is where a lot of the use cases will come in the enterprise. How do I take out labor? How do I take out cost? How do I automate it? And how do I do this in a sustainable fashion? Um, so there are four pillars we are seeing which are critical in getting agentic to the company. So first one is inferencing. Inferencing so far has been, a lot of it is distributed in the cloud. You have these major AI vendors or potentially self-hosting in the cloud or use one of the token providers. What we are seeing now is that inferencing is going to explode in volumes. You're going from, producing hundreds to thousands of tokens to having these very long thought chains, and you may produce, tens of thousands to hundreds of thousands of tokens just to do a single invocation. So runtime suddenly goes from seconds to minutes to tens of minutes. And this is the main limitation is memory bandwidth on the inferencing systems. And memory bandwidth doesn't, I mean, it's kind of doubling every 2 to 3 years, but there will be a quite substantial increase in capacity. We simply need to put down because we don't have the memory bandwidth to solve all these tokens which get generated. Second really big component is, and the prior two presenters already mentioned that, there's a large component of retrieval augmented generation. You need to get your enterprise data somehow into the model that you make decisions which are not, just trained from global public knowledge, but it's actually specific to your enterprise. And this is where we are seeing a lot of solutions which go, how do you take in an enterprise, how do you take the data and the knowledge of a company and make it accessible so that the models actually operate on that proprietary information? Nobody wants to have that proprietary information being public. So there's like a protective mode around this. And in order to build anything which is agentic, you pretty much need a good rack solution which protects the IP, and not only from, against outsiders, but even internally. You want to potentially put up isolation firewalls so that one organization cannot peek into the other organization's data. This may be for compliance reasons, security reasons, etc. Number three is you need APIs. How do you make your agents actually do something? Right now, the mainstream goes towards MCP, Model Context Protocol. We are currently going through the MCPification of all our services. In many cases, you can just layer it on top of your web APIs. We went through 15 years of microservices. And so can you layer your MCP interfaces, but make them simplify them sufficiently so that an agent can actually pick up and is not confused. So you don't want to have like a 7-level nested SQL query being sent, but you want to do something simple which an agent can actually handle. And so there's development involved. In some cases, we literally take the help manuals and for like CLIs, which are much more written towards human use cases, and make them the MCP interface instead of actually using a web API. Simply web APIs sometimes have state, and they are not necessarily written for human consumption, but for programmer. And then the last one is, how do you actually build your agents? And so that's the new part, where we need to constrain what the agent is doing. We want to be able to actually observe it. We want to be able to guide it so that the agent doesn't fall off the rails. So the good news is agents are code. So we just saw that in the two prior presentations. There is a development process, and this is always the good thing when the moment we can map this onto something we know, which is in this case software development, things just fall in place. Your organizational structure doesn't need to change. So on the development side, you develop prompts, you develop a state graph, you develop, where does the agent go along? What are the constraints? Then you need your MCP server. So if you're not in the middle of MCPifying your enterprise, I would recommend that you start because you will have to. Then you need to pick an agentic framework. LangChain was mentioned, LangGraph, any of those go. And then there, of course, are no-code tools. We saw them in the prior presentations. We have our own version, which is called Watson X, so that you have low or no code that business users can actually do the development. And I think this will be one of the big productivity gains that business users can actually do it by themselves. Um, by the way, I'm not currently reading the chat message. I will go through and then I will go and answer in the chat. So then the next one is testing. So this is where I see the biggest challenge with traditional software development. Testing, we engineers know how to do unit tests, they know how to do regression tests, but they are incredibly poor at dealing with uncertainty and probabilities. And so you need to build out your test coverage, and you need to do this in a structured way that you can actually make positive statements about that the system is doing the correct thing. My last company I founded was a self-driving car company. We were operating in like 200,000 test samples to make sure that cars don't crash. In this case, now in enterprise settings, we often look at regression tests and unit tests, which are in the order of like 2 to 500, sometimes 1,000 samples. And you need to build out a strategy how you are getting field feedback even once you deployed your software, because you cannot simply test all these text use cases. So you see it from ChatGPT. You have the little thumbs up, thumbs down. That's the data collection method of actually testing the software and building out the regression tests. So when you are putting agents into production, you need to come up with a strategy how you harvest those user feedbacks, in particular for all the negative examples, so that your engineering team can actually test it and then build out the regression sets. So this is something which really requires software architecture and product architecture. It doesn't come for free. Third one is software lifecycle. So assume that you will always have model updates. Right now, we are releasing a major model update every year, which is a fundamental shift in the architecture. And then we are releasing a new model every ballparkish 3 months. And so with that, every model update, you will have prompt updates. So your model kind of slightly shifts. The main model updates, where what we are currently seeing is once a year, you get probably like a 3x improvement. So a model which used to be 20 billion parameters is then 8, and an 8 billion parameter model becomes a 3 billion parameter models. So these models become smaller and more powerful. A lot of the pre-training has shifted to alignment. So alignment is now by far the largest compute requirement. So you may also switch between model families over time. So in your software lifecycle, you need to actually plan for that. It also has an impact on if software is shipped and forgotten, you may actually have to sustain models really long term. So when you think about the software lifecycle management, if you have software which is just a fire and forget, you may actually create a long-term dependency on models where you need to actually have hardware in place so that you can still run those models. You may run models which are 5 years old if you look, further out. So then if you don't want to do that, there will be prompt updates coming all the time. And then, of course, you have the model graph changes. Then finally, on the compliance side, you need to put guardrails around tools that they don't delete your database or your file system. You need to have access controls, deal with data privacy, and then there's a huge component of security and compliance. So in general, when you look at the challenges you will run into, I peeled out six. So data privacy in the enterprise really critical, compliance. Then you need to somehow figure out your failure modes. And the failure modes could actually be customer facing, right? Internal customers or external customers. And you need to deal with this. So you want to test for them. You want to test your confidence. There's interesting technology in we call it A-lore, which is attached lore. So you can actually peek inside of the model and figure out what the probability of hallucination is so that you potentially don't even give the model output to an external user. There's a whole security component. Skills is a huge problem in the enterprise, so you need to figure out how you upskill your engineering department, and then you need to deal with risk and liability, in particular when you're externally facing. So, for example, you don't want to have promise a loan which then you cannot solve simply because the model made a mistake. So there are liability issues which on the business side, while the technology may work, the business side may actually consider it too risky. Okay, so why us? Why IBM? So we are doing continuous innovation across the stack. We are actually we picked a strategy which is a horizontally integrated AI stack, and I will show you how this looks like. Sorry, vertically integrated AI stack. I will show you a picture. We are building our own models. The models are called Granite. We are fully indemnifying the customer. So if there's, for example, copyright violations or so, the IBM corporation stands behind these models. We are fully publishing all the information, how the models were trained. We make sure there's no hate and profanity in it, etc. And those models are smaller models. We are focusing on small language models to make sure that the cost when you actually run them in production at scale does not eat all your profits. Then we build a toolbox around it to make this whole thing happen. And then we also have the talent and the expertise because we are interfacing with so many customers. So from a stack perspective, this looks like at the bottom we have our infrastructure. That's where I'm sitting. So there's the different brands I will talk about in a second. Then we made a decision as IBM to be a hybrid cloud provider. So it's on-premise and in the cloud. We are agnostic to the cloud provider. But effectively everything is layered on Red Hat OpenShift, which is a Kubernetes flavor of, or it's Red Hat's Kubernetes flavor. And then on top of that, we layer three more parts. So one is we have our own AI and data platform, which we call What's Next. There's an AI part, there's a data part, and there's a governance part. So governance is really about making sure that there is compliance, which is really, from our perspective, a critical component when you're in regulated industries, so that you can actually make statements: where did my data come from? What replies did I send? Everything is archived, so you can actually track lineage and you can track anything which ever happened with your system. And then on top of that, we layer our AI products. We are focusing on a bunch of industries which we are seeing from our customers. So one is digital labor, with Orchestrate being What's Next, Orchestrate being the product which allows you to build these agents. But then we also have assistants. There's generic assistants and code assistants. So in many cases, when you go to a telco and there's a chat window, there's a high chance that that chat window is actually backed by What's Next. Then we are on IT automation, security, sustainability, application modernization, in particular for our own platforms. We see a big demand for mainframe modernization. And then as a company on top, we have our consulting business with a center of excellence for Gen AI and client engineering. And so we are taking those systems and work directly with the customers to actually put these systems into production. Now, by doing that, we are really on the forefront. We also eat our own dog food. And so there is a lot of learning which actually goes through the stack simply because we are exposed to so many different AI use cases in the industry. And then we work with system integrators, software and SaaS partners. So now going one step, the bottom layer, that's where I'm sitting in the organization. We are really trying to figure out how can we make or take these AI workloads and make them enterprise ready. And so our like probably everybody knows then the mainframe family, which is IBM Z, and Linux One, which is kind of the cornerstone of the financial industry. We are extending that and also the IBM Power Platform with the Spire adapter, which is our own silicon. So we are building a platform where you get the same reliability of enterprise platforms. So for example, for mainframe, that's 8 nines, which is better than a nuclear power plant. And then we have the AI capabilities on board. You can put up to, I think right now, 48 of these adapters in the system so that you can run AI workloads directly on the mainframe platform. And this is for both Gen AI, but it's also for more traditional ML. So we see tens of thousands of credit card transaction fraud predictions, which need to clear within a millisecond. And so we have these scale out AI platforms for both Z and P. And then we have on the other side a Fusion, this hyperconverged infrastructure. And here this is a Kubernetes in a box, but it comes with AI acceleration, so you can pretty much roll this thing in, and within 24 hours you can have a ready to go Kubernetes platform, including AI capabilities, and we can put that software stack I just showed you, the layer cake on top of it. And then a really important one is storage scale. So that one is used in like training infrastructure. So the challenge is if you sit on 10, 20, 30,000 GPUs and you're training your network, how do you get the data to that network? And you're in the petabyte scale training sets. So storage scale, we are certified by NVIDIA and AMD right now in the process that we can do DMA direct all the way into the GPU, like load data sets in very, very large training clusters and put them into a GPU so that the GPUs are busy and you don't lose money. Another platform which is announced is content-aware storage. Is also on our storage scale platform where you can take a file system and we automatically do all the ragging for you. So you pretty much just install a piece of software and then your complete NFS server gets indexed and becomes accessible for RAG. And then the last one is IBM Cloud. We are a public and private cloud provider. We picked a strategy where we are working with all the hardware vendors. So we have NVIDIA, we have a partnership with Intel with Gaudi 3, and we have AMD with the MI300, and we are going to 355 so that you can pick the best platform, hardware platform for your specific use case. We are also offering inferencing as a service directly in the cloud. We are eating our own dog food, so the stuff runs on our own cloud. So in general, we are trying to build a system, a layer cake where you can pick and choose whatever you need for your enterprise. But we are looking really from the top down, including the models, the runtimes, etc., so that you can actually move the stuff into production. And we are eating our own dog food so that we can come in and actually help you to implement this in your enterprise setting. Okay, so that was a quick run through. Thank you very much. And any questions? It would be great if someone could read them out.
I don't know if I don't know if there's a specific question based on what you just showed,
Yep.
to be transparent. I'll ask one question, which is, it seems that you're using your own dog food to do your digital transformation. Where have you seen the biggest impact?
So right now we are seeing a huge impact on support functions where you kind of are, it's a document-based business. So we see a very large impact internally in HR, for example. So we have thousands and thousands of HR agents. Like IBM is a 275,000 people company. And so we are seeing in all these support functions immediate impact. So instead of calling an 800 number, you go directly to a chat agent, and you can interface with your employee employment record, etc. Deal with the standard processes, and they are all moving towards agentic. So that's on the business side. But then IT infrastructure, we are moving a good chunk of the IT management, monitoring, configuration, etc., into agentic workloads. And so we are taking out a good chunk of these mundane, just management tasks in IT and substituting them with agentic workloads. And that's like a huge time saver, and B, it actually also makes people happy. Whereas who wants to manage,
Yeah.
thousands of servers and just babysit them
Yeah,
and
the
actually
grunt work.
move
Yeah.
towards more productive stuff, right?
Yeah.
So the first wave was really first code generation, so that developers got productivity gains, and now we are moving into these more operational tasks where we are seeing a huge uptick.
Thank you so much, Volkmar. Hopefully we'll have you again here to take us what's the
Okay.
next steps
I
what you
didn't
guys are
demo
doing.
anything, and maybe next time I demo
Yeah,
something,
exactly. Yeah, we'll go
it's probably a
live.
good mix of, like higher level to, here is a Python program.